Continuing on with problem number 9 on section 1.1, page 3, we just identified the equation for the tuition costs, 105 times how many credit hours you take, plus $50 admission fee. And they remind us here that H is the number of credit hours taken. So now we have a student that's billed $1,415. How can we figure out how many credits she's taken? Well, we need to decide where this goes. We have C, which is the cost, right here. And we have H, which is the number of credit hours taken. So I look here and I see this is the cost. So that means this has to go in place of cost. So we rewrite this equation with 1415 in place of cost, and set it equal to the rest of the equation, and then we can solve. So whenever I have an equation like this that has my variable on the left, I immediately just flip the equation over because I like it on the left, I don't like it on the right. So if I see it on the right like this, I just immediately flip it over to the left. And then I can just do my equation solving. So my h's are already on the left, so anything without an h, which we call a constant, remember, gets moved to the right. So 105h equals 1415 minus 50, 1365. And then we have to do the opposite of multiply by 105, which will be divide by 105. And so we already have our 1365 in the calculator, so we can just hit divided by, and it takes your answer, 105. So what is that 13? What's 13? So H equals 13. What would be the label of that? So look up here, H is the number of credit hours. Anytime you have a word problem in this class and the next class, in any math class you take, your last step is always to put a units label on it to show whoever looks at this that you understand what it is you found. So you see your H, you look up here. So this person, what's her name? Susie? Oh, just a student. So if the student is paying $1,415, that means they're taking 13 credit hours that semester. Okay, and sometimes, like if it was a paper pencil test, they would also make you write a sentence about it. If a student's bill is $1,415, comma, they are taking 13 credit hours. Something to that effect. Okay, now we're going to study the special cases. The special cases are where we have no solution and we have all real numbers as our solutions. So with these special cases, you'll notice our variables are going to be gone. So there'll be no variables in the problem. So you'll always know, because students go, well, geez, I never know when to write no solution or all real numbers. How do you know when to do it? It's when your variables cancel. You don't have any variables on the left and you don't have any variables on the right. So you will know when to use them. So conditional equations is an equation that is true for some values of the variable but false for others. So when we were doing ones like these earlier today, we didn't quite have ones this easy. We would get a single solution, x equals 4, and that was called conditional. So conditional means we have at least one solution. Contradictions would be if we have x minus 4 equals x plus 3, when I go to bring my x to the other side, minus 1x minus 1x, My x's cancel here and they cancel here. So 1x minus 1x is 0. 1x minus 1x is 0. So what I'm left with is negative 4 equals 3. Well, this is called a contradiction because it's false. Negative 4 never equals 3. So then we would say, well, because it's false, it's going to be no solution. And these are all the different ways you can write it. You can write it with an open solution set. You can write it with the no solution, or you can write it with the symbol. I wonder if I have someone at my door, but I don't know if there's a pause symbol. Okay, so the type we worked with throughout the whole first 3 pages was conditional. They all had one solution. So if our x's cancel and we get something that's not true, we say, well, that's false. That's never going to be true. We write no solution using one of these 3 symbols. So we can use the empty set symbol, write no solution, or use the no solution. What's that called? Icon? No solution, symbol, whatever. And then the third type that we're going to see is, okay, so we have an equation, 2x plus 6 equals 2x plus 6. We go to subtract 2x from both sides, and we get 6 equals 6. Because the 2x cancels there, the 2x cancels there. Well, this time it's not a false solution. 6 does equal 6. It's always true. So when it's always true, we write all real numbers, or this is the interval notation for all real numbers. So let's take our highlighter and do this. So never true, we write no solution. If it's always true, we write all real numbers. Oops, I forgot to underline all real numbers. And if the x's don't cancel and we just get something, then we just write what it is. Okay, so let's try these on the next page. So we still have to follow the steps from page 1. So page 1 says clear parentheses, clear fractions, combine like terms. So that's always the first steps. So I see some parentheses here, and I see a lot of people miss this one on the test because they lose track of the fact that they are distributing a negative, not a positive. So we're distributing negative 2 to each of these. So this is going to be 8x in front, just like normal. Now this is going to be negative 10. And this is going to be negative 8x, because a negative times a positive, negative, negative times a positive, negative, and then we get negative 10. So see anything happening there? 8x minus 8x, isn't that 0? Don't write 0x. 0 times x is still 0, so it's just 0. That's how you should think of it, just 0. So then we have what's left. Negative 10 equals negative 10. So as I said, when your x's cancel, you have 2 choices. It's either no solution or it's all real numbers. And this is the step that tells us. I have some students in the past that every time the x cancel, they just write no solution. Well, you're only going to be right half the time. So if it's always true, negative 10 is always equal to negative 10, then we write all real numbers. So don't just jump and write no solution every time your x's cancel. So half the time it's going to be all real numbers, half the time it's going to be no solution. When this is false, no solution. When it's true, all real numbers. And remember, 8x minus 8x is 0. Don't write 0x, it's just 0. Okay, so let's do this next one. So again, I see I'm distributing a negative, so I'm going to circle it. So that leaves me with 30x minus 10 minus 30x equals 10. So 30x, and negative times a positive, negative 10, and negative times a positive, negative 30x equals 10. So look at my x's. Again, they're going to cancel. 30 minus 30 is 0. So what do I have left now? I have something left, but this time it's not true. Negative 10 never equals 10. So this is false. So that leads me to write no solution. So that is 2 really good examples. And guess what? I put one of those on your test. So you're either going to have an all real numbers or a no solution. So let's go back and highlight the ones for you to study. So you should study 10. You should study 11 because like I said, one of those 2 is going to be on there. And then I also put a fraction one on there. So let's highlight number 2 from page 1. I think that was one of our best fraction ones. So 2 of those 3 highlighted problems will be on your test. And they're the first 2 problems on your test. I don't remember if it's the fraction first and the no solution or the fraction second and the all real numbers, but they will be your first 2 questions on your test. Okay, so fraction problem number 2 on page 1 you should highlight, and then the 2 no solution all real numbers problem. One of those 2. I think I put one on your practice test and then I put the other one on the real test, just to remind you about both of them. Okay, so true all real numbers, false no solution. Okay, so this is kind of a weird problem, but I see that 3 goes into 6, 2 goes into 6, 2 goes into 4, 2 goes into 6. So there's no need to ever clear your parentheses on this problem because as you distribute, it's going to clear the parentheses for you. So watch what happens here. And I only noticed that the denominators were going into the numbers, the denominators going into the outer number. That's how I figured it out. So half of 4x, so this is times, so what's half of 4x? 2x. Minus, what's half of 6? 3. And then if you can't do fractions very well in your head, that's okay. Just use your calculator. So this would be 6 times 1/3. So 6, and this is always a times because there's no symbol there, times 1 fraction bar 3 is 2, and then don't forget your x. And then a positive times a negative would be negative, and this is half of 6, which is 3. Or again, you can type it on your calculator, 6 times negative 1 fraction bar 2, and you see it is negative 3 plus 9. So I have 2x minus 3 equals, and see the like terms over here? 9 minus 3 is positive 6. Okay, so as we distributed, it got rid of all the fractions. So now we have to subtract our 2x, and do you see how the x's are canceling? So I want you in your head to figure out which one this is before I say it. So I get 0 there, I get 0 there. Don't write 0x. 0x is 0. It will just confuse you. So you bring down what's left and you say, is that true or is that false? Well, it's a false statement. Negative 3 never equals 6. So we write no solution. And there you go. That's the end of 1.1.